Hi guys, welcome back to YouTube channel Foundation Chemistry AB. So today we are going to talk about de Broglie relationship. So this will be highly beneficial for class 11th and 12th students. So I have a simple message for you guys. Please think for innovation, be creative, learn everywhere, anytime and help to learn others. So today we are going to talk about the de Broglie equation or relationship. So de Broglie suggested that electrons, protons and neutrons or atoms etc. So that means matter has both particle and wave characteristics. That means the dual characteristic. So according to Einstein, he gave this equation we know that E equal to mc square. And according to Planck, the relationship is E equal to h nu or that is equal to E Sc upon lambda. So now if we equate equation 1 and 2, so Sc lambda, Hc upon lambda equal to mc square. So lambda will be equal to h upon mc. So for a particle moving with velocity v, so lambda will be equal to h upon mv. So mv is the p, that is the momentum, h upon p. So lambda is directly proportional to 1 upon p. So this is applicable for microscopic particle, where lambda corresponds to wave character, that is called de Broglie wavelength, and p corresponds to particle character, that is the momentum. And the limitation is for larger particles lambda is too small to be measured. And for electron have wave character moving with velocity v and is accelerated by a potential difference v volt. So as we know, the kinetic energy that is half mv square. So that is you can measure in terms of electron volt. So v will be equal to 2 ev upon m square root. So where v is less than c, that is the speed of light. And we know lambda equal to h upon mv, so that we can put the value of v here. So h upon m into square root of 2 ev upon m. So mm cancels out, so only remains square root of m. So that becomes h upon square root of 2m ev. So that becomes now h upon 2m ke. So this suggests that equation 4, every particle can be considered to have an associated wavelength and wave properties. And in 1924, Louis de Broglie suggested that if radiation, which originally a wave, can behave as a particle, then small objects like electron, which definitely are particle like character, behave as waves. So his statement, although sounded unconvincing initially, was indeed proved to be true experimentally in later years. So then Davison Germer did this experiment. So this is the electron wave around the nucleus. So Davison Germer used electron beam instead of X-rays and found that an electron beam accelerated through a potential difference about 100 volt behaves like X-rays and gives the same diffraction pattern for nickel crystal. So using the Einstein's concept, an equation identical to that for photon can be used for very small microparticles. Micro means very small particles. So that is lambda upon hb. So lambda equal to h upon p. So where lambda equal to wavelength of matter wave. So let's try some problems. So calculate the de Broglie wavelength of an electron traveling with a speed equal to 10% of a speed of light. So c equal to velocity of light, that is 3 into 10 to the power 8 meter per second. So the speed of electron will be 10% of a speed of light. So 3 into 10 to the power 8, 3 into 10 to the power 8 into 10%. So that means equal to 3 into 10 to the power 7 meter per second. And using the relationship, de Broglie relationship, lambda equal to h upon mv. So h value know 6.62 into 10 to the minus 34 joule second, and mass of electron is 9.1 into 10 to the minus 31 kg, and v we have just found out velocity 3 into 10 to the power 7 meter per second. So the answer found to be 2.43 into 10 to the minus 11 meter. Similarly, let's try another problem. Calculate the momentum of a particle which has de Broglie wavelength of 0.1 nanometer. So we know the relationship lambda equal to h upon p. So or p equal to h upon lambda. So H value we know, the Planck's constant 6.62 into 10 to the minus 34 joule second, and here the wavelength is equal to 0.1 nanometer. So 0.1 into 10 to the minus 9 meter. So it is found to be 6.62 into 10 to the minus 24 kg meter per second. So let's try another problem. Calculate the linear momentum of photons of wavelength 750 nanometer. What speed does an electron need to travel to have same linear momentum? So here what is given? The wavelength, that is 750 nanometer. So lambda we know equal to h upon p. So h value we know. So 6.62 into 10 to the minus 34 joule second, and p will be equal to what? H upon lambda. So that will be equal to 750 into 10 to the power minus 9 meter. 1 nanometer equal to 10 to the minus 9 meter. So that p becomes this much, 8.83 into 10 to the minus 28 kg meter per second. And we know p equal to m into v, mass into velocity. So v will be equal to p upon m. So this is the value of p, 8.83 into 10 to the minus 28 kg meter per second divided by mass of electron. So 9.1 into 10 to the minus 31 kg. So the answer found to be 0.97 into 10 to the power 3 meter per second. So please subscribe to our channel Foundation Chemistry AB. So this is also available in the website www.foundationchemistryab.com. Class UG and PG, this is the channel Chemistry Live UG PG. So this is a simple step towards e-learning, making life better. Thank you all for learning.